Hello everyone and welcome to my channel, and in today's video we'll be doing circles, all theorems and all properties that are a part of your semester 2 syllabus 2022 examination. So let's start. The first property is the angles in the same segment are equal. So this is a circle and there is a chord AB that I have drawn, and all the angles from chord AB in the segment that they go, like if they're in the same segment, you can see there are two segments. This one, the smaller one that is below AB, and the one that is above AB, and the angles in the same segment, all angles, they'll be equal. So like this, we can also say this one in other words, like all the angles subtended by the same chord in the same segment will be equal. So angle ACB is equal to angle ADB and AEB angle, this one. So all three of them are equal. Second property is angle at the center is twice the angle at the circumference. Angle at the center, so O is the center of the circle, and again AB is an arc here, or you can also imagine AB as a chord here. So some people are not very comfortable with arc and all, so I think chord is a better way. So just imagine that AB is a line here, it is a chord in the circle, and it subtends an angle at the center O, and this chord AB also subtends an angle at at the circumference. So these angles, how are they related? They are from the same chord, of course, but if you see the property here, angle at the center is twice the angle at the circumference. So meaning angle at the center is the bigger angle, and it will be 2 times the angle here. So meaning AOB is equal to 2 ACB angle. Third property is angles subtended by the same chord are equal. This one we talked about. So the figure will be the same to show. So the angles that are subtended by the same chord, they will be equal. Then fourth property is in a circle, the angle in a semicircle is a right angle. So there's a circle with center O, and AB is the diameter which cuts the circle into 2 equal halves. Now the angle that AB makes at the circumference will always be 90 degree. You can make one here also, or anywhere in this in this semicircle. If the diameter is making any angle, it will always be 90 degree. So angle ACB is 90 degree, and any angle subtended by the diameter on the circumference is 90 degree, if you want to say it in simpler words. Then property 5, the sum of opposite angles of a cyclic quadrilateral is 180 degree or supplementary. What is a cyclic quadrilateral? It is a quadrilateral in a circle, and it has all of its sides touching the circumference of the circle. Now if I draw a circle, and I draw a quadrilateral in the circle which does not touch whose all of the sides, all 4 sides do not touch the circumference of the circle, that will not be called a cyclic quadrilateral. So you have to remember, cyclic quadrilateral is a quadrilateral whose all 4 sides touch the circumference of the circle. Then ABCD is a quadrilateral here in a circle and cyclic quadrilateral, and if you see the sum of angle A and sum of angle C, so they are opposite angles and their sum is equal to 180. Same goes for angle B and angle D. They are opposite angles in the cyclic quadrilateral and their sum is equal to 180 degree. Sixth property is when a side of a cyclic quadrilateral is produced, the exterior angle is equal to the interior opposite angle. So I have a cyclic quadrilateral ABCD, and suppose I extend this side AB outside the circle. I extend it outside the circumference of the circle, outside the boundary. So this CBX, I have named this part X, this line. So this CBX angle will be equal to the the interior opposite angle. So if this is the side, so just imagine there is an angle here. So what will be the opposite angle for this angle? So for B angle, D is the opposite angle. So same way, for angle CBX, the interior opposite angle will be angle ADC. So they will be equal. So exterior angle CBX is equal to interior angle ADC. Now moving on to the next property, the radius and tangent at any point of contact are perpendicular. So I have a circle with center O, and OT is the radius here, and T is also the tangent. It is coming in contact with the circle at point T, the tangent. And if I draw, like if my radius falls on the tangent, so anytime, anywhere, whenever the radius is coming in contact with the tangent, it will be a 90-degree angle. But the condition here is that it should be a radius. So if it's not a radius, if it's any other chord which is coming in contact with the the tangent, then it may draw a 90-degree angle, but it may not also. But this is a property that radius and tangent at any point of contact are perpendicular to each other, that is, they form a 90-degree angle. Property 8, if two tangents are drawn from the same exterior point, then they are equal. Two tangents, okay, they are drawn from the same exterior point, meaning I have a point P over here which is quite far from the circle, but from point P I have two tangents coming, and they are touching the circle at point A and B respectively. So PA and PB, they will be equal. So if it's a trick question, it usually does come in exams, or it can be asked that how many tangents can be drawn from an exterior point. So the answer is two tangents. Only two tangents can be drawn from the same exterior point. So here PA and PB are equal. Next property is two tangents drawn from the same exterior point will always subtend equal angles at the center. So O is the center of the circle here, and we know that PA and PB are equal. So how did we get this result? We proved the two triangles here, if you can see, PAO and PBO. We proved them congruent and we got this result. So angle AOP, that is angle AOP is equal to angle BOP. So the angles they make here with the center, they will be equal. The next property is, if two tangents are drawn from the same exterior point, the tangents are equally inclined to the line joining the point and the center of the circle. Meaning, if again it seems quite complicated like this, so let's break it down. If two tangents are drawn from the same exterior point, alright, we know that PA and PB will be equal. The tangents are equally inclined to the line joining the center, to the line joining the point and the center of the circle. Meaning, angle APO is equal to angle BPO. Since we know that PA and PB are already equal, we also know that angle AOP and angle BOP are equal, and OP is a common line. So again, by CP/CT rule, we can say that these two angles are equal. So angle APO and angle BPO are equal. Property 11, if two tangents are drawn from the same exterior point, right, the angle between the tangents is supplementary of the angle that they subtend at the center. So if two tangents are drawn from the same exterior point, you understood, the angle between the tangents, so angle between the tangents, this angle is supplementary of the angle that they subtend at the center. So they subtend the angle at the center, that is AOB, and APB is the angle between the two tangents. So angle AOB will be angle AOB plus angle APO will be 180 degree. Then property 12, if two chords of a circle intersect internally or externally, then the lengths of their segments are equal. Here we have the internal case, so they are intersecting internally. I have a chord AB and I have a chord CD, and they are intersecting at the point P. So now the relation here is that AP into PB, okay, is equal to CP into PD. And I'll give you a trick to remember this, that wherever they are intersecting, the point of their intersection, you always have to take it from there, like the segment will be from there, segment of the chord. So AP, right, and PB, then CP and PD, like that. And same goes for the case like when they are intersecting externally, like here at point P, they will be, so the segments will be equal. So PA again PA, so take everything from the point P. So PA into PB is equal to PC into PD, right? So the same thing here. The next property is property 13. If a chord and a tangent intersect externally, then the product of the lengths of the segments of the chord is equal to the square of the length of the tangent from the point of contact to the point of intersection. So it seems very complicated if we read like this. So let's look at a diagrammatic representation. We have a circle here and there is a chord AB, and I have extended this chord AB to meet point P over here, and same, so P point, and I have a tangent T coming out like from point P only, from the exterior point. So tangent and chord are they are intersecting externally at point P. So what will happen here is PA into PB. So the both segments of the chord, so the product of the segments of the chord is equal to the square of the tangent. So PA into PB is equal to PT square. Alright. Last property we have here, property 14. Angles in alternate segment are equal. So children generally have a lot of problem understanding this one, and it's, to be honest, it's not really difficult. So let's try. We have a circle here with center O, and we have a tangent here which is meeting the circle at point P, and we have a chord here, chord SR, right? Now the angle that this chord PR is making with the tangent P here, tangent PB, this angle will be equal to the opposite interior, in the alternate segment. So this is the segment here, these are two segments. So segment here, the PR chord is dividing the circle into two segments, into two arcs, like major arc and minor arc, you can say. So the angle here is equal to the angle in the alternate segment here, this one. Trick to understand this, so wherever the line is making, like say this is the angle, this is the exterior angle, or the angle that you're getting, and you need to find out the alternate, this angle in its alternate segment. So what will you do? There is a line here, so this line, so the line, so the angle in front of this line will be your angle in the alternate segment. We have another case here. So in this case, yeah, angle RPB is equal to angle PSR, and we have another case here. I'm sorry because the diagram is a little messy, because I myself had problem understanding this at first, but now I think I have understood. So we have I haven't made the center here, and P is the point of contact of the tangent to the circle, and APB is the thing, and we have this chord QP here, and the angle here, the angle RPA here, if you see. So I told you, whatever line it makes the angle with, we have to look at the opposite, right, the alternate one. So this is the line, RP is the line it's making the angle with, so the angle in front of RP will be the one in alternate segment, right? So in this case, angle APR is equal to angle PQR. I hope you understood the trick and you got the whole thing, the whole property. And this summarizes all the properties and all the theorems that are coming in your semester 2 examinations. So thank you so much for watching.